Hello, and welcome to this episode of Mrs. Mulvey's Math and Physics Movies. In this episode, I'm going to explain about energy and loops and height. And we're going to look at scenarios with and without friction. Take a look at this setup where I have the block and it's going to slide down the ramp, go around the loop, and I'll actually add a ramp on the other side as well. So the block's going to slide down, go around the loop, and come up the ramp like this. Now, at the very beginning of this scenario, before this block is released, all the energy is gravitational potential energy, which is mass times gravity times its initial height, which I'm going to call h sub I. Now, the first scenario we're going to look at is going to be without friction. We're going to ignore friction. Hi. Anyway, so we're going to ignore friction. So what happens is this. The block's going to slide down the ramp, and as I've discussed in my other videos, and if you did not view those videos, I suggest you view those first. One is called Energy and Loops, and the other is called Energy and Loops and Forces. Anyway, as the block slides down, goes around the loop, and comes back up, remember that this energy in the system is exactly the same amount at any given point in time. It's just that sometimes it's all potential energy. Sometimes when it's right here, it's part potential, gravitational potential energy and kinetic energy. Sometimes when it's down here at the lowest point, it's all kinetic energy. But as this block slides around, goes around the loop, it comes up here. Eventually, it's going to come to a stop. It's going to come to a stop at the exact same height from which it started. The angle of the ramp does not matter. Remember that gravitational potential energy is based on the height. Doesn't matter if that thing's going to drop straight down or slide down a ramp. And so, because this energy stays the same, we're not losing any to friction. Because this energy stays the same the whole time, as the block goes around the loop and slides up the ramp, where it comes to a stop, it's going to be at the exact same height from where it started. It can't go higher than where it started because then it would have more energy than it started with, and that's not a possibility. And so the block's going to stop at the exact same height from which it started, right here, h sub I. It's clear about the only reason this block can continue around the loop. The only reason this block can continue around the loop is because at this point, the energy is m times g times 2r. That is the gravitational potential energy plus 1/2 mv squared. So in order to have a velocity here, or an energy here, that's 1/2 mv squared, this mg2r, representing the gravitational potential energy, has to be lower than the mgh, the energy in the entire system. Because one more time, the energy right here, these two put together equal the mgh, the initial energy in the system. That means the initial energy in the system is more than the gravitational potential energy at this point, and it's more than the kinetic energy at this point. If I were to increase the size of this loop and make this point P at the same height that the block started at, then what that would mean is at this exact point, if my loop was bigger now, like this, let's see if I can do this. Okay, pretend that's a good circle. Notice I've made point P now at the exact same height that the block started at. That means at this point, this mg2r energy is the exact same height as the mgh energy. These two would be equal to each other, and I would have no kinetic energy. So at this point, the block would stop moving if these were the same height. The block would stop moving, and if it stops moving, it's going to fall straight down. So the idea here is that this block has to start from a higher position than the highest point on the loop. Or the other way to think about it is, let me just get rid of this. The loop, the top of the loop has to be at a lower height than the starting position of the block. Now let's talk about when energy is lost to friction. So now I'm going to give this block some friction here. Friction is heat and sound. I'm going to, there. The red represents friction. So all the way down, this block is going to be experiencing friction. And all the way around, the block's going to be experiencing friction. So if we're imagining now this block is experiencing friction, and it's enough friction so that it's losing enough energy that when it gets up here, it's not going to have enough energy to keep going. That means the block's going to stop and fall. So if I would like to have the block continue on, I want to start it from the same height. I want it to go all the way down the ramp and around the loop. I need to do one of two things. I either need to increase the height, which I just said I want to start it from the same height, or what I could do then is lower this height. Because if I lower this height, that's going to make this value a lower value, and that can compensate for the energy that's been lost to friction. So I'd like to be very clear. At this highest point in the loop, the energy in the system depends on two things. Well, really three things if we're looking at friction. It would depend on the coefficient of friction. But it also depends on how fast the object's moving here and the radius of the circle. Lowering the radius of the circle, lowering the height of the circle, lowers the energy for the gravitational potential energy. And so if I'm now experiencing friction, lowering this height of the circle will decrease the gravitational potential energy and hopefully make up for the force of, not the force of friction, I'm sorry, the energy lost to friction. So note that gravitational potential energy at this point plus the kinetic energy plus the energy lost to friction. Now these three things together will make up the energy that was there at the beginning, the gravitational potential energy, the mgh. And so as I would raise the energy lost to friction, I would have to lower the gravitational potential energy right here, and I do that by lowering the loop. So lowering this can compensate for an increased value here, keeping everything in balance. In general, I think it's helpful just to remember this. When we're talking about energy being lost to friction, there are two ways to make sure this block sliding down the ramp goes all the way around. We either can add energy at the beginning of the scenario by raising the starting height and starting with a greater gravitational potential energy, or I can lower the height of the loop, requiring less gravitational potential energy there and therefore compensating for the energy lost to friction. So that's it for this video. As always, please let me know if you have any questions. Bye-bye.